Okay, so this is 2 beta. And if I'm looking at the PDF, this is the empirical rule. So in the textbook, we're on page 118. And the empirical rule is this. So we have the picture from yesterday. Here's the center. Here's one step to the right, one standard deviation to the right. Here's one step to the left. One step left or right from the center captures 68.26% of the area of the curve. So if you think back to what they said in chapter 1, standard deviation is how much something typically varies from the center. Well, the reason they're saying that is because one step left or right will capture more than 2/3 of the data. 2 steps left or right, 95% of the data. And 3 steps left or right, 99.7% of the data. So that answers 2 questions. How we came up with this window from -3 to 3, because that captures all but 3 out of 1,000 data points. And also, why you get 200 for writing your name on the SATs. Well, the issue is this. These numbers, if we put numbers under here for SAT scores, what they did for the SATs was they took this military test and they just worked backwards and said, well, what would be an average score on the verbal and the math? So they said, let's say 1,000. You know, it's an easy number to deal with. So that'd be 500 for each component. So they said, well, we'll work backwards. We'll make the step 100. So this would represent a score of 500, 600, 700, 800, 400, 300, 200. See, they worked from the center. That's how you got that 200. They worked from 500, left or right. So this captures 997 of every 1,000 SAT test takers. There's 3 kids. They might be over here. They might be over there. Well, we can't be concerned about those 3 kids. If they're over here, they got an 800, they're fine. If they're over here, they didn't really try. Now, yesterday we found the area under that rectangular uniform distribution. But it's more important to find the area under the normal distribution. So we have these calculator key sequences, and I'm going to go over this with you on your calculator, but you can come back here for the prompts. So we go here, ready? Second distribution. Now 1, the only time you're going to use 1 is when you put it in your y equals. I think I neglected to do that with you until yesterday, but that's when you use 1. 1 is the normal probability density function. That's what PDF stands for. And you see these paired as you go down, PDF, CDF, PDF, CDF. Normal cumulative distribution function is 2. So if I type 2, now, if you have the older calculator, your prompts may be a little different. You may just get this. You're going to type the same numbers we're doing. And here, for the lower bound, that's the lowest number the calculator's memory stores. -1 times 10 to the 99. You don't need to worry about this. So if you don't have this, all you have to do is put in a small number. Well, ready? A number far to the left. So you put in -100, you'll get the same output. Because anything different from this would be truncated on the display anyway. So if I take this all the way to the left, and let's say I say my upper bound is 0, where the center, mu is 0, and the step is 1. I'm going to paste it on the home screen. But you need to think about this. You need to think about what answer you would expect to get without just putting enter. You would expect to get 0.5. How come? Because we went all the way from the left and we stopped at the y-axis. That's half the area of the curve. How if we did this? Second enter. What if we test the empirical rule? Remember what it said? Between -1 and 1, how much of the area of the curve is going to be captured? It says 0.6826. I'm having trouble moving this. There's your 6826. That really truncates to 27. But that's where it's coming from. The calculator's giving you this. That's the area under the curve, and it's more exact than the empirical rule. Now, when you go, we told you this to store that window, zoom, memory, recall. I don't have it in this window, so I'm going to have to put it in there. So I'm going to do this. You should be good. -3. Did I push the right window? -3 to 3 and -2/10 to 5/10. Push graph. There's the window I want. And I push zoom, memory, store. Now I'm going to go back. Second distribution. Instead of going to 2, I'm going to go over the right and go to draw. And it'll draw it for me. So I push 1. Instead of going from -1 to 1, let's go from -2 to 2. Center 0, step is 1. Now we can change these, but they're the default settings. Now, not only does it draw the picture for you, it gives you the area of the curve. So we told you the empirical rule tells you that that's 95% of the area of the curve. It's a guideline. It's close. It's off by 45/10,000ths. So when you start doing this, it's a good idea to use draw. Then when you get comfortable with it, then it's more efficient to do normal CDF. Now, when you draw something, you got to be careful. Because when you draw this, and then I wanted another area that was closer, this picture is going to stay there. So this number will change, but it's deceiving. So when you draw it, you want to go to second, draw 1, and it'll clear the drawing. Okay? So, you also have this. You have inverse norm. It'll work backwards. It's like Jeopardy. You tell the calculator the area that's enclosed, and it'll tell you the z-score, the standardized score. The z steps are standardized distribution, or the steps, standard deviations, okay? So for inverse norm, I type second distribution, 3. So I want the area. I don't know. Let's say, now think about this, 0.5 plus 0.5 times 0.6826. What did I just do? I said the area in quadrant 2, to the left of the y-axis, plus half the area enclosed by 1 standard deviation left or right. Think about what it's going to give you. It gives you a z-score of 1. Does that make sense? Because 1 that's the z-score now. That's the standardized score that captured this area of the curve, which is 8426. All right, this is 8413. This is 3413, half of it, plus the 0.5 is 8413. Now, in your textbook, I need you to do this. If you have a hard copy, it's going to be easier. Go to the back and you go to the tables. Now, if you have the electronic copy, this is all the way in the back of the book, as far back as you can go, but the pages aren't numbered. And you will see these tables. And I'm on table T2. It's the same information as you can get on your calculator. So nobody, ready, they give you this table during the AP test. You're not going to prefer the table to the calculator. There is no non-calculator component to the test. So if you were in calculus last year, we were anticipating half the test being non-calculator. It was only because of the circumstances that they let you use the calculator in the whole test. They always let you use the calculator in the whole test in statistics. But they could embed the table in a multiple choice question. So I'm on table T2, and I look at the upper left. There's the z-scores in units and tenths. And across the top are the hundredths values. So if you look at 0.00, that gives you 0.5, because 0.5 is to the left of that. If I go to 1.00, I see the 8413, which corresponds to what we just did. So it's hard for me to communicate the table to you in this, this setting, but we'll get back to that. Like once we get back in the building, you get a copy of that table as part of your formula sheet. All right, but I'm more concerned with if they embedded part of the table in the question and asked you to interpret it. So you're going to do this. You're going to go to these two questions, 51 and 53. Now, 51 is a really helpful question because it deals with the data from yesterday about the potato chips. And you're going to draw the curve and then put the numbers under there, kind of like we tried to do yesterday. And 53 also deals with that potato chip data. Okay? Okay, so 51. Ready? Here's the picture. This is the same picture from yesterday. There's a graph link of the curve. These are the standardized scores. 0 is a z-score of 0. It's how far you are from the mean. You're right on it. 1 step to the right, 2 steps to the right, 3 steps to the right, to the left. For the potato chips, the mean number of ounces in the potato chips bags was 9 1200ths, and the standard deviation was 500ths. So we count out 500ths to the right, 500ths to the left. So this picture was there yesterday with these numbers, but now they're taking, that was for the alpha lesson. 9 2/10 ounces is 2 standard deviations to the left of the mean. It's right here. From -2 to 2 standard deviations encloses 95%, which is all but 5% of the end of the curve. So that would leave, since the graph's symmetric, 2.5% at each tail. So if you got a potato chip bag with 9 2/100 ounces, that would be more than only 2.5% of the potato chips bag sold. From -1 to 1 standard deviations, that's the 6826. So we go by the empirical rule, we truncate it. There's 32% in the two tails put together. That's 16% in each tail. So at 9.07 ounces, you got more potato chips than 16% of the buyers. You're in the 16th percentile. And then we teased this a little bit yesterday. They average 9 ounces of chips on the bag. You can't put 9 ounces here. You can't set the machines to put 9 ounces in the bag, because then 50% of the customers are going to be unhappy. So what did they do? They worked backwards. 9, take away the 9 1200s. How far you are, you're trying to get the Z-score. How far you are from the center. Divided by the step. Gives you a Z-score of -2.4. And now what? Well, I use -1,000 instead of the scientific notation. Comma -2.4, comma 0, comma 1. And you get this. Less than 1% of the potato chip bags would weigh less than 9 ounces. So, they're willing to accept that if you had, less than 1% of the customers complaining about getting cheated, that's acceptable. Okay. Now we're going to do 59 together. I ask you to do that, but see if this makes sense to you. So 59. The question is, find the proportion of observations in a standard normal distribution that satisfies these statements. The Z-score is bigger than -1.66. I have this graph link here. Start at -1.66, go to a high number. Start at -1.66, go to a high number. 95% of the area of the curve is to the right of -1.66. Between -1.66 and 2.85, just made them where you're going. From there to there, center 0, steps 1, just about 95% of the area of the curve. So you'll get more comfortable with this as you do the exercises. But I understand right now, your focus for tomorrow is on chapter 1. It's not going to be a stressful thing.